I think that's my cue. Thank you all for joining me this morning. I'm sure we'll have a few more trickle in for those of you who, for the people that got to the buses late to get over here from the keynote. In case you're wondering if you're in the right location, hopefully you are. You're here to learn about smart savings, Amazon EC2 cost optimization strategies. This is a 200 level session, so it is meant to be pretty accessible. We're not going to go deep into architectures or code samples or anything like that, but there is some assumed knowledge, right? So we assume you know things like EC2 at a general concept, and we're going to go beyond that on how you can apply some best practices to achieve smart savings. I meant to introduce myself before I go on. So my name's Boyd McGeechy. I'm the director of go-to-market for our networking and compute services. I've worked at AWS now for about 12 years in total. I've been working in the Spot business specifically for about the last eight or 9 years now, helping customers maximize savings. For those of you who aren't aware, the Spot instances, which we will talk about, since 2013, Spot instances have helped customers save over $10 billion over the cost of on-demand. Right, so very significant savings. Hopefully some of you are already taking advantage of that. For those of you who aren't, hopefully you know the way to do it by the end of this presentation to get yourself started. A few things. I was told not to just talk about work, to maybe introduce myself and tell you something about me. I performed in the Olympics. And don't look like that. I performed, I wasn't competitive. I was in the opening ceremony of the Sydney Olympics way back in 2000. So that's a fun tidbit if you want to come and ask me about that. Maybe a way to get to know me a little bit better. All right, so let's jump into it. The agenda for today. So first we'll talk about what is a smart saving, right? Pretty important for me to help, I guess, make sure that we're thinking about optimizing in the right way that sets yourself up for long-term success. So we'll talk about what that means. We'll talk about the AWS services and features. We'll start with some of the more simple aspects of EC2 and cost optimization, then we'll move into some of the more advanced aspects where we're seeing customers sort of get continually reap additional savings benefits, additional efficiency improvements throughout their compute platform and to some level to broad AWS use overall. What are the decisions? How do you think about making sure that you are driving smart savings? We'll talk about that as well. And then of course, we'll share a little bit about how customers are really maximizing savings in 2023 and where I expect or really believe with high levels of confidence they're going to continue to reap those benefits and continue to see improved efficiency through 2024 as well. All right, so let's jump into it. So what do I mean by smart savings? For those of you who don't know, Inspector Lestrange is the person that always told Sherlock Holmes that they were wrong. I was told not everyone knows this reference. So the point is not all savings are good savings. So what are some examples of bad savings? And I saw a lot of these. From the beginning of the pandemic through to the worsening economic outlook at the end of 2022, we did see customers make some decisions that I would call suboptimal for long-term success, even though they do drive short-term savings, right? So a bad saving is one that limits your ability to innovate in the future on behalf of your customers. It restricts your business's ability to respond to your changing customers' demand, and of course, it can impact your end customers negatively. So what do I mean by that? Well, first and foremost, limit your ability to innovate in the future. One of the worst examples we saw really early on at the end of 2022 when customers were really quickly looking to see if they could optimize savings. Some customers went from completely non-optimized environments and said, you know what, let's just delete a bunch of data in S3. Let's just delete a bunch of extra data in our data warehouse. Let's just get rid of it. And that does drive immediate savings. In the cloud, you stop paying if you delete that storage and reduce your costs. Then, they started thinking about, well, what am I going to do with my generative AI strategy? Did some of that data was that data useful to my generative AI strategy or my ML AI strategy in general, my data lake strategy, right? So maybe not the smartest way to save. Some better ways to maybe tier storage or take advantage of some new offerings that have come out more recently. Restrict the business's ability to respond to customers' demand. The other thing that I saw which really hurt because we spent a lot of time helping customers, move from on-premises into the cloud and then modernize. But the reality is, let's be honest, in that process of modernization, you're often double paying for at least a little bit, right? You're building the new modern, maybe serverless platform, microservices, containerized platform that's going to enable you to move faster, your developers to move even quicker. But it does cost you money in the immediate term because you still have to run your old system, right? So we actually saw some customers choose to pause or even end modernization strategies, right? And then again, how do you respond to changing customer demands, changing environments, and again, things like generative AI, which you're probably already sick of from the 2.5 hours this morning. But obviously, it's something that a lot of businesses are thinking about. and it's restricted their ability. And then the final one, some customers stopped a migration into the cloud. And again, that's that idea that, hey, while you're in that migration period, you've got to continue to operate your data centers. You haven't gotten rid of them yet. And moving into the cloud, you're still building out your application, so you are having to pay some amount for your cloud services while you're in that process. So you can stop doing that. And we saw some customers stop doing that and stop buying hardware on premises as well, right? And so what does that end up meaning? Well, in most scenarios, that's going to mean that when your customers really need your services, when the demand comes in, you're going to provide a worse experience for them. So your customers maybe don't end up purchasing, or if they do purchase, maybe it was such a bad experience they're not coming back. So these are what I mean by bad savings, right? They do save you money, but they don't really set you up for success long term. So we want to avoid these, and the strategies we talk about today, for the most part, completely avoid these pitfalls. So good savings, obviously the inverse, right? Enable that agility through flexibility, enable rapid innovation in a lean cost structure. This is something that I talk about with customers all the time when it comes to Spot, right? If you can run your development environment on Spot, all of a sudden, not only have you reduced the cost of your existing development environment, you've reduced the cost to innovate and do more things on behalf of your customers to develop new features, functionality, whatever it may be. And of course, providing customers with equal or better performance while you're optimizing. And I did ask a few people at the beginning. Sadly, only one person said Graviton was one of the things that they were most excited about in the keynote announcement. But that's a great example, right? We saw customers able to migrate to Graviton, improve their price performance by up to 40%, and actually get lower latency, better customer experiences out of their platform, right? So that's what I mean by smart savings. All right, so now that we've gotten that through, I just want to quickly talk about the sort of overall agenda. So these are the sort of 3 simple steps we'll talk about at the beginning before we get into the more advanced things. I'm going to start with scaling, then we'll talk about right-sizing, downscaling, and then we'll talk about obviously optimizing those purchase options. And what you're actually seeing here, this is anonymized, but this is a real-world customer experience as they went through the optimization strategy I'm going to lay out for you. Their cost to serve users, right? So that's why that function goes down. Their user base went up, but their cost per user went down dramatically, as you see through these optimizations. So I have to start with the first thing. Now, I imagine a lot of you are AWS customers today, but I assume there's a few of you in the audience, maybe a show of hands, that still have some things operating in a data center on premises, that type of thing. Okay, significant portion still. So I have to do the first thing first. My first way that I would recommend optimizing is by moving that into the cloud, okay? Most of you are going to be well aware of these concepts, but just to make sure we're all starting from the same point, right? When you're in the traditional environment, you have to purchase hardware, right? And you have to try to predict ahead of your customer demand how much hardware you're going to need, and nobody is perfect at doing that, okay? So this is an example where you're purchasing maybe every 3 months, block purchases maybe every 6 months, expanding your data centers, and you're trying to forecast your actual usage and trying to keep that data center footprint as small as possible ahead of that actual usage. But again, when you're doing purchases every 3, 6, 12 months, there's just no way your forecasts are going to be as accurate as you might like them to be. And so the first step, obviously, first thing to point out is when you're over-provisioned, you're wasting money, right? When you're under-provisioned, your customers are getting that bad experience we talked about earlier, right? Maybe the website's not loading or it's running really slow. It's taking me 30 seconds to make a purchase, which nobody puts up with anymore, unless you're in Australia. If you're Australian, you might put up with it because our internet still sucks. I don't know if I should say that. Might have to edit that out. All right, so now obviously the whole thing you're going to see when you move to AWS, the one thing, the main thing, the elastic compute cloud, you're meant to match that capacity with exactly what your customers need at any point in time. Because when you're leveraging the AWS cloud EC2, our scale is so significant that for many customers, it appears effectively infinite, right? Because we have that elasticity available for you to scale up and do it just in time. Okay, so first things first, we would really, really suggest moving your infrastructure into the cloud. This is a study from back in February 2022 that we did with the Hackett group. And I just wanted to point out, like, it's 47% reduction in IT costs. That's great. There's a lot of things that go into that. But the stat that really jumped out at me, and the reason I just wanted to present this one here, is 40% reduction in over-provisioned infrastructure. Okay? Remember that when we start talking about scaling in just a moment. And I also wanted to mention a customer who's gone through this process, who I've worked with directly for many, many years now. I've been very, very privileged to work with Skyscanner very closely. I've been a Skyscanner customer since way back in at least, I think, 2010, when I first started booking international vacations from Australia. It's very expensive to travel from Australia, so anything you can do to get cheaper tickets, you absolutely do. And Skyscanner was my way to do that. And so I was thrilled years later when I started working for AWS that I got to work with them to help them migrate out of their data centers and into AWS, right? And as you see from this quote, if you've been able to read it already, don't bother if you haven't, it used to take them 6 to 7 weeks to launch a service. And at AWS, it can take them 15 minutes. And so that means Skyscanner was able to not only reduce their operating costs by up to 70%, they were able to increase their agility and scalability, and now there's more features, right? More features that I get to take advantage of, that any of you who are customers of Skyscanner get to take advantage of. And again, even things like that performance you get out of the platform with that scalability, the results that you get when you do a search on Skyscanner come through really, really quickly because they're using all of that elasticity. And they're doing a lot of this on Spot instances. They're very public about their work with Spot. And so they're really able to totally minimize their costs, which again, when I'm going to a platform to try to book cheap tickets, it's pretty useful to know they're also doing everything they can to reduce their costs so that they can pass those savings on to me as much as possible. All right, now let's get into the stuff for the workloads that are already running on AWS today, okay? So I already mentioned this, but it's called the Elastic Compute Cloud. We call it EC2, right? I'm sure not many of you say Elastic Compute Cloud day to day, but I feel like it's really easy to forget Elastic. It is one of the core premises of EC2. It's why it's in the name, right? If you are not using EC2 in an elastic way, you are not using it to the fullest of its spirit, of what it's designed for, of its way to deliver that efficiency and performance that you expect. Okay, it's a similar type of graph as we talked about before, right? We want to avoid waste. We want to meet peak business demand with great performance at the lowest possible cost. Still working good. So we want to match those instances right up to that very middle. Now, I'm sure a lot of you have looked at these concepts and thought about them before and thought about how you can make those applications actually scale. So I wanted to highlight a few of the tools that customers use, and some of the newer ones that maybe you're less aware of for those customers that have been using AWS for many, many years now, when it comes to auto-scaling groups. Because if you're not aware of it, we actually have multiple different scaling policy options for you. If you're a long-time EC2 customer, long-time AWS user, you are almost certainly, hopefully, almost certainly aware of simple or step scaling, right? As its name suggests, it is pretty simple. You set metrics. You might say, hey, my application starts performing really poorly at 60% utilization, so I'm going to set my scaling metric to 45%. When CPU gets to 45, add a couple extra nodes, because I never want to get to 60 and give my customers that bad experience. So super popular, very commonly used tool for scaling, but it is the original. If this is what you're using and you haven't explored any of these other three, something that you should check out. We'll talk about predictive scaling in particular. But so target tracking, thermostat-like, it was really for customers. Some customers found it difficult to set the right scale up policies and scale down policies, right? Because you want to obviously manage the difference in metrics so that you don't end up scaling up, then scaling down, then scaling up. And so target tracking was a really easy way for us to, an easier way for customers to sort of just set a thermostat-like target, or inflation-like target, right? We want it to be at around about 50% utilization, right? Never above, never below, or a little bit above, a little bit below, that's fine, but we don't want it to massively deviate from that. And so that's what target tracking does. You can just set a metric, we'll automatically add and remove nodes and try to keep your metric at your compute so that your metric is as close to that as possible. And I'm talking about CPU here. You obviously don't need to use CPU. In fact, for most applications, we don't recommend using CPU. You can scale on any custom metric that you want to scale on. For these services, right? You just need to feed that custom metric into CloudWatch. Auto-scaling can pick it up and start scaling on that on your behalf. So you might scale based on, user count, connection count, whatever it may be. CPU is just an example, right? Don't get too fixated on that if that's not really what matters to your application. How many of you are running workloads on AWS today and haven't started scaling at all? Wow. Okay, some honesty, good. Thank you. I was going to say, I've never seen an audience say zero, none at all. Okay, maybe just for the two of you, but anyone else listen in as well. So scheduled scaling. This is a really, really powerful tool to get people over the hump of what it means to scale, right? Because again, as its name suggests, you can just set a schedule. And so I really encourage anyone who hasn't started scaling or is mainly scaling maybe a few applications, maybe new ones, stuff that they've just freshly developed, but their core compute is still costing them a fortune, sitting there not scaling at all. Scheduled scaling. Get your development environment, your testing environment, whatever it may be. Get that thing turning off when your developers go home. Get that thing turning back on when your developers come to work, right? If you turn servers off at night and on the weekends, you're saving over 65%, right? Because that's just how numbers work, right? 9 to 5, 5 days a week is not most of the week. So simple things like just scaling. And this is an added benefit. We see a lot of people are reluctant to go into scaling in production because they haven't tested it all, right? And so just enforcing this, going into your development environment and making it turn off at nighttime, you will find issues, right? It's not going to work perfectly the first day. Your developers are going to come in, some of them are going to be pissed off, right? Hey, my environment's not working, I'm missing some stuff that I expected in my memory or wherever it may be. But that's going to train them. And in fact, years ago, Yelp presented at reInvent about how they were able to use that as a reinforcement platform. And so by moving to things like scaling and things like Spot in their development environment, it forces their developers to start thinking about what happens when things fail. Because again, this isn't just about cost optimizing to reduce your AWS costs. Right? If you're being efficient, if you're doing smart savings, you also want to ensure if a server happens to fail during peak load, your customers aren't impacted. Right? You want those customers to come back. Cost savings, of course, in the name, it's about the cost, but you can't lose track of top line as well. Right? If you save money in your costs and it causes your customers to not come back, you are not really saving anything. Okay? So scheduled scaling, simple, great way to sort of push and challenge your team, particularly for those of you who might be in sort of a central platform, infrastructure, cloud team, and there's teams everywhere saying, oh no, we can't scale, I can't do that, no, you know how it is, developers don't want to have to put in this work. Dev environments, nights and weekends, it's off, right? Very simple. All right, then we'll spend a little bit on predictive scaling, okay? Predictive scaling, again, as its name suggests, these names are actually pretty clear for us. So with predictive scaling, I love it because it does what the spirit of auto-scaling always was to me, right? You put your application inside an auto-scaling group. We learn based on the traffic patterns, based on the metrics inside that auto-scaling group on those instances. And then where it is predictable, we will predict it and scale up on your behalf ahead of time. Now, this has a couple of really awesome benefits, right? Number one, we talked earlier about step scaling, have to set it 45 in order to make sure you don't trigger over 60%. With predictive scaling, we can scale just in time, right? Based on your historical previous loads, we can scale it just in time so that you don't have hardware sitting there idle 10, 15 minutes waiting for that traffic to come in. Equally, you might trigger a 45%, it goes to 46%, it goes back down to 40%. Well, you just added a server for no reason. You weren't going to hit 6. Predictive scaling is going to use those predictions so it scales intelligently. Of course, this can be paired with other scaling options because predictive scaling doesn't scale you down. So you do have to make your own scale down decisions. So a lot of people just set up simple step scaling policies to scale down on that. Also, as the name sort of suggests, if it's unpredictable, if you've got a big event that we've never seen before, you need to manage your own sort of scaling policies for that because we're not omnipresent. We can't know things that we don't know, so we can only use that historical data. And the final extra point that I really like to point out here, it does work within your boundaries. So predictive scaling can be a scary concept. What if it just goes to infinity and my bill goes to infinity and my customers don't come? You can set boundaries. Just like every auto-scaling group, you can set caps, limits, maxes. You don't need to let the thing scale to infinity. You can set those reasonable caps and control that yourself, okay? One final thing, and this is, I don't want to bully the developers too much up here for too long, but again, we hear from some people, hey, it takes too long for my application to get started. You know, we see this a huge amount with traditional enterprise applications. Things running on things like a Windows operating system often have significant, very long bootstrapping processes that can take 10s, 20s, even we've seen customers take over an hour to get an instance from when we've started it and given it to them into a point where it can actually take traffic and deliver some value on behalf of you, right? And so if you have that challenge today and you are not scaling because it takes you too long to instantiate and get an instance up and running, or what we also saw some customers do, if you're managing your own warm pools, right, effectively scaling at 10% so that you can be ready at 60%, right, so you're massively scaling over the top, go check out warm pools. What we do is we instantiate the instance and then we put it into a stop state on your behalf. An autoscaling group is aware of that, right? It's aware that it's got these instances that are in a stop state that are going to be much faster when we get those instances out of the stop state and get them going. Because they're in a stop state, when an instance is in a stop state, you do not pay for the instance, right? You're just paying for that EBS storage that's got that instantiation sitting on it. So it is much more cost-effective than running your own warm pools. And again, almost certainly much more cost-effective than just leaving instances sitting there running 24/7. This gives you, again, a real-world example from a customer here. You can see the time it took them to sort of get an instance up and running in order to handle that traffic before warm pools. I don't know if you can actually squint in and see that, but the gap between, in the top one, the gap between the orange line and the red line, when the orange line peaks and then the red line peaks, is 10 minutes. Once they've turned on warm pools, you see it takes them less than a minute to get that server up and running into production for their application, right? So immediately you're saving nine minutes of CPU, right? When you pay by the second, that's 9 minutes of savings. That's awesome. But not only that, imagine if this spike was unpredictable, right? Now all of a sudden, 1 minute, and you can catch up and deliver that performance that your customers expect instead of waiting 10 minutes. And again, ending up with frustrated customers that aren't very happy. So we talked about the sort of common use cases, right? Spiky workloads, long instantiation times, and it's a great alternative to having to manually scale, which a lot of customers do when they have these really long, slow instantiation times today. All right, as we move through this, okay, so we've gone through auto scaling. Now let's talk a little bit about just sizing it right. You could put either of these in either way. This is the order that I recommend exploring options though, right? Think about scaling and right sizing before you even look at purchase options for the most part. That's why that's coming third here. So what do we mean by size it right? Well, I was just told, and I updated these slides, we now have over 750 different instance types available. So that's a lot, right? It can be overwhelming. And again, developers might say, I don't want to learn all that crap, right? I don't want to spend all the time learning 750 plus different instance types so I can work out what's the best instance for me. Good news, we actually have a system for that now. We have this thing called attribute-based instance selection. It was launched a year or two ago now. And it sort of does what the name suggests. You can put in specs, CPU, memory, network, generation of instance, different sort of ratios that might matter for your application. And then you can say, now go get me the instance that's the cheapest available. And what I really love about this, obviously, it gives you that flexibility, right? Your developers are maybe already, particularly those of you in the containers world, they're used to defining the container specs that they need, what CPU, what memory does this container need? So going and applying that in this model with attribute-based instance selection is pretty natural, right? They don't need to learn those 750 different instance types. It can just go select them. But the thing I really like, we launched the M7i Flex earlier this year. Can't remember exactly when now. But we launched the M7i Flex earlier this year. And we quickly saw a very large user of EC2 become an enormous user of M7i Flex. We're like, wow, that's fantastic. You've already migrated. You've already moved. M7i Flex provides 19% better price performance over M6i, right? So almost 20% price performance improvement by this migration. And it turned out the customer didn't even know they'd made the migration. Now, it might sound scary, but they had their system set up so that it wasn't scary for them. They could handle that. They were ready to see if anything went wrong. But they just automatically noticed, hey, your specs actually match this new instance type that meets or exceeds your specifications, and it's cheaper than the one that we were launching yesterday. So I'm just going to start launching it, right? So it's a really easy way to just automatically keep on top of the absolute best instances that AWS is offering for your application without having to keep track of 750 plus different instance types. The other thing that I want to point out, using attribute-based instance selection initially can be scary. I would also say even though developers might know what they put in their containers, they might not really know what their CPU and memory needs are. Generally, when you ask a developer what size server do they need, they'll say the biggest one. And so on top of after you've first done that launch, after you've started making these moves, don't worry about having to make sure the initial specs is perfect, because we offer the AWS Compute Optimizer for free. Since the launch of this thing, we've sent out over 20 billion recommendations. By the way, we don't send out recommendations if there's nothing to recommend, okay? So that's 20 billion plus times that we have seen an opportunity for an AWS customer of EC2 to select an instance that is cheaper and delivers the same specs that the application actually needs, right? Because with the AWS Compute Optimizer, we're monitoring your real-world workloads, right? We're looking at what's running on the instance. right? And by default, we're just looking at sort of some low-level metrics like CPU. You can opt in and actually get higher-level metrics like memory and that type of thing on top of this, so we can have really deep insights and make very intelligent recommendations on the instances for you to use. And the reason I bring this up here in the right-sizing section is, again, with EC2, you're paying by the second. With the AWS Compute Optimizer, you're getting recommendations on a regular basis, assuming you're not perfectly optimized, and none of you are, because there's not a single account inside of AWS that's perfectly optimized. So with the AWS Compute Optimizer, we're going to send you those recommendations, and again, you can just respond to them whenever it makes sense. Do you change the specs in attribute-based instance selection, or do you just change the instance that's running whenever it is? You can make that call, you can manage that yourself, but I encourage you to come back to this at least on a monthly basis, right? Because if you're not coming back to this at least on a monthly basis, you're almost certainly missing out on additional opportunities, because this isn't just about misdefining the specs initially, right? Hopefully you're still developing and deploying new applications, new features, new functionality, new performance optimizations, whatever it may be, and the best instance for you is going to change, right? So AWS Compute Optimizer, semi-regular basis, check it out. It's just going to automate the process of sizing it right, okay? So it's an important step, but the reason I put it second is because you can sort of just do this naturally over time with these tools, right? You don't need to front load a lot of this work to think about it the right way. All right, the third sort of, I guess, basic common thing that everyone should be doing is what I'd describe these things as, is the compute purchase options. I imagine all of you have seen this slide, so I'm not going to spend much time on it. We have on-demand, we have savings plans, we have spot, right? On-demand, great way to get started. Pay by the second. When you don't need it anymore, give it back to us. However, with savings plans, I imagine a lot of you are aware of it. It's a super, super popular option these days. Savings plans, a few things to make sure that you're aware of, because I still see even very big savings plans customers sort of living in a reserved instance mindset, if you've been a long-time user. So compute savings plans is the most popular type of savings plans, and it's the most popular type because we really built it based on customer feedback from the reserved instance offering. Customers wanted greater flexibility. They wanted greater automation in applying their savings globally. And so with the compute savings plans, we offer discounts of up to 66% over the on-demand price. But the really cool thing, the flexibility that I'm talking about, is we will automatically search for any instance in any region, instance family, I've got to read the list actually, it's so long, instance family, instance size, tenancy, operating system, or compute service option. So effectively with the compute savings plans, you should think about it as committing to spend a certain amount on compute services anywhere in the world, on any instance type, any instance family, for the next 1 to 3 years, whatever it may be that you're signing up for from a compute savings plan perspective. And on top of that, and this is the thing that I really want to push for you, if you're not ready to scale, if you're not ready to right size, go buy some compute savings plans immediately, right? It is great for 24/7 workloads, but if you're not scaling, you currently have a 24/7 workload. If you think right now, your team comes and tells you, in 6 months we'll be scaling, I guarantee you it'll be 18 months. Wait, I can't say guarantee, I take that back. I don't guarantee it'll be 18 months, but you know it's not actually going to be 6 months. So time and time again, I see customers make the decision to defer these commitment products where you can commit and save a fortune because they think we're just about to do this, we're just about to do that. Well, if you're not ready, go buy them. But if you are just about to move to serverless, to Fargate or Lambda, this actually still applies over there as well. So don't let that be an excuse, right? Compute savings plans, if you migrate your application from EC2 to Fargate, EC2 to Lambda, it's going to automatically go with you, right? We're going to, again, just search and try to find the best way to maximize your savings. If you are very confident you're going to keep running a specific type of server for 1 to 3 years, however, you can save even more money with the instance savings plans, right? Really good for things like databases, right? If you're self-managing a database on EC2, the instance savings plan is going to save you up to 72%, so you get additional savings. It's still flexible, but there's a little bit less flexibility, right? So now you're actually committing to a specific instance family in a specific region for the period of the commitment, 12 months to 3 years, depending again on which one you select there. But it provides you the absolute deepest possible discounts, right, with instance savings plans. And I'll also just, I guess, briefly mention the SageMaker savings plans as well. The compute savings plans do not apply over to SageMaker. SageMaker has their own savings plans offering, which provides up to 64% discount. And again, it's pretty flexible across all of the SageMaker portfolio in how you apply that. But it, different usage types, instance families, sizes, regions, that type of thing. So if you haven't, check out savings plans. If you're still thinking about savings plans in a reserved instance mindset, right? If you're thinking about, well, we need to really know the instance type, we really need to know the region, we might even need to know the size, you're wasting a lot of time. Just go buy some compute savings plans, work out what your sort of normal hourly spend is, and that's about what the right thing should be for you. And again, if you're going to move an application from Singapore to Kuala Lumpur or to Sydney or to somewhere else in the world, doesn't matter. We'll just chase it and apply the savings automatically with compute savings plans. Hopefully you're convinced. Don't need to spend a lot of time on this next slide. Savings plans is super duper popular, really, really flexible. Leverage some. If you're still on reserved instances and you have a reason for that, I would love to meet you afterwards and hear what that reason would be. It's fine to use them, just don't really know why people do anymore. All right, now let's talk about Spot instances. As I mentioned at the beginning, I've been working in the Spot business for about the last, I needed to say this. Savings plans. I mentioned Spot saved customers $10 billion since 2013. I love Spot, so it sort of hurts me to say this next one. Savings plans only came out in 2019. It's already saved customers $30 billion over the price of on-demand. That's how popular it is, right? It's really, really popular. And it's saving customers a ton of money versus the on-demand price. So let's talk about Spot though, because that is near and dear to my heart and a great way to maximize savings for elastic workloads. So first, Spot is the same infrastructure, fundamentally 100%. It is the same infrastructure. Before it is launched, it's like Schrodinger's cat. It is on-demand and Spot. It is just spare EC2 capacity. So it's got the same performance, same security while it's running, okay? The thing about Spot is we reserve the right to reclaim that capacity from you with a 2-minute warning. That's because Spot is truly spare capacity. And so when it comes to running applications on Spot, there's a couple of things that I really just want you to know. If you're going to take away one thing and try to run on Spot, it'll be the next slide. But workloads, fault tolerant and flexible. So we'll talk about what flexible really means here when it comes to Spot. The applications that tend to be fault tolerant are those that are either loosely coupled or stateless or have sort of a retry capability is something that we see a lot in HPC, big data, ML applications where you're going to run a lot of that on Spot. And if a server happens to go, you just restart it and you're saving so much money, it's worthwhile. So what do we mean by flexibility? Because most people don't try Spot if they're not fault tolerant. Most people really understand if you can't handle a server going away, then Spot is not for you. But what some people sort of misunderstand is the importance of flexibility. Because when we talk about flexibility, we say there's sort of 3 or 4 vectors of flexibility. There's instance flexibility, there's availability zone flexibility, there's region flexibility, and then there's time flexibility. Now, I don't really consider time flexibility to be a true thing. Generally, if you have an application that is so time flexible you do not care when it runs, the cheapest way for you to run that workload is just to not run it, because you don't care when you get the results back. So I really don't meet many people out there that are truly time flexible. Unless you happen to be working at a university and you're willing to wait 3, 4, 6 months for your results because you've got a lot of stuff going on, I really never meet anyone in a business that is truly time flexible. Similarly, region flexibility is not necessarily the easiest thing to do, and not necessarily for some applications that might need to actually be close to a database or be close to a storage environment, high performance storage, region flexibility just isn't necessarily possible. So I'm going to ignore those two. I don't want to talk about them. I don't even really want to talk about availability zone flexibility because for those of you who are in here, hopefully you're all aware of why you are or are not multi-AZ. Most people know multi-AZ is going to drive great availability for your applications, but for some workloads, it can cost you money because it does cost money to transfer across availability zones, right? So you know that, you know why you operate a certain way. And so I'm going to ignore that one as well. If you want to use Spot, you must be instance flexible and fault tolerant, okay? Why do you have to be instance flexible? So I sort of tell this joke, it always lands flat, but I'm going to try it again. Like, imagine if you were sitting there and your partner was in the car next to you. And I say to my wife, Claire, hey, Claire, can you call the hotel? We need to get a reservation. If she called the hotel and she said, hey, is room 304 available? Oh, okay. Okay, no worries, and hung up. She turned and told me, hey, room 304, it's not available. I'd be like, what about 404 or 305? Like, why do we care what room we're in? It's just the hotel. And that's sort of the same thing with EC2, right? When it comes to Spot, we have so many different instance types, those 750 different instance types that I was talking about. Almost certainly there are multiple different instance types that work really, really well for your application. And while at any point in time, in a specific availability zone, in a specific region, somewhere in the world, we might not have your absolute number one option when it comes to Spot instances. It's really, really unlikely we won't have your second best option. Super unlikely we won't have your third best option, right? And so that's how customers are able to run consistently and run a lot of serious workloads, non-time flexible workloads customers call production workloads on Spot instances, is by saying, hey, when I'm interrupted, I'm just gonna quickly and automatically replace that Spot instance with another one, right? And so just, again, if you can see this, we've got 3 different instance families here, the M6G, the C6I, the C6G. Within each of those families, there's like 6 to 10 different sizes. Every single one of those families and sizes is an independent capacity pool to Spot customers in the short term, okay? So that means we might not have C6I12XL, but we probably have 18XL or 8XL, right? And if you can just run the right amount of servers to service your application, it's gonna work really well. Or maybe we have the C7I, sorry, or the C5, right? So there's lots of different ways to think about this flexibility option, but I really just wanna challenge you, if you're going to use Spot, this isn't optional. It's no more optional than being fault tolerant, in my experience and opinion. You might get lucky for a month, for 2 months, for 3 months, running on a single instance type on Spot, but then you'll have an experience where that one's not available for a week, right? And you're gonna think, hey, Spot's broken. But it's not. If you just check the hotel room next door, it probably would have been open, right? And not only do I say that, I don't even just want you to trust me, so I'm going through these slides now. Attribute-based instance selection is going to automate this process for you, right? I mentioned that earlier. It's a great way to just optimize general EC2 usage and just automatically select the instance type that best meets your specs. Well, for Spot, it can do that, and on top of that, if your number one best instance isn't available, it can automatically fail over to the next one on your behalf as well, right? So it can just handle that process of finding the Spot capacity on your behalf. And if you want to, you can actually check out this, sorry, Jimmy. You can check this out in a tool called Spot Placement Score, where you can actually go and test yourself. Am I flexible enough to run this application on Spot, yes or no? We've seen some really fantastic workflows from customers that use the Spot Placement Score. This is a service that comes at no additional cost. And they'll just automate the workflow and say, hey, if we're not getting a score above 6 or 7, add additional instance types. Challenge the developer or the infrastructure manager to add additional instance types to my specs. And these are the results that you'll see. Right, on the left-hand side, we have a customer who's requesting 1,000 vCPUs, 32 vCPU minimum per box, and 64 gigs of memory. And we can see time and time again in every region that's displayed here, we actually get 9 out of 10 for a Spot Placement Score. That's pretty good, right? And it's pretty much as good as you're ever gonna get with Spot. However, if you only put in a single instance type, and again, requested just 1,000 vCPUs, on the left-hand side, you see, sorry, your right-hand side, my left, you see not a single region has a score above 3, right? And so that's what Spot Placement Score is trying to communicate with you. Yeah, I know you're gonna be fault tolerant if you're using Spot. Are you flexible enough? And if you're getting 3s, 1s, 2s, and 3s, you're not flexible enough to run on Spot, right? Or you're gonna have to be time flexible. You know what I said about time flexibility. It doesn't really exist, right? You're gonna get yelled at. All right, so let's quickly just wrap on Spot instances here before we move on to some of the slightly more advanced, or I guess the continuous optimization opportunities for customers. With Spot instance, I've talked about this flexibility concept. What a lot of customers say is, hey, which pool has the most capacity? Hey, can you just tell us which one has the most capacity and is really cheap at the moment? We can't tell you how much capacity we have. We're not gonna tell you that. Doesn't matter how many times you ask, we're not gonna answer that question. But we built an allocation strategy which we think does what you want us to do on your behalf, which is if you give us 10 different instance types, we will automatically search through those 10 instance types and find where are the capacity pools that are deep enough that you're not gonna have a terrible experience, and then pick the cheapest of those 10, right? That's why it's called the price capacity optimized strategy. If you're getting started with Spot, or if you're already using Spot and you're not using this strategy, highly recommend jumping on it today. It's just the one that sort of maximizes savings while minimizing interruptions, which is what people generally are trying to do when it comes to Spot. Now, just high-level message here is think about how this works, how the balance across these options works within your workload, right? Things like, well, video streaming is a really obvious one. Don't run video streaming on Spot, terrible idea. I don't want my Zoom call interrupted, right? Nobody does. So don't run things like video conferencing, even game servers that really require high levels of state and sort of that instantaneous live human-to-human communication, terrible idea. However, over on the analytics side, maybe you should run most of it on Spot. And so have a think about the nature of your applications and those workloads. And again, I think we have up here, do we have, yeah, databases over on the far left-hand side for you all. Obviously, databases should just be 100% savings plans. Don't even think about Spot or on demand, right? As soon as you've gone through that right sizing process, purchase that. Okay, so these are the relatively simple things that if you haven't done, I really encourage you to go apply immediately after that. If you have applied all these, and you've kindly stayed with us for the last 30 minutes as we went through them anyway, then I would encourage you to start looking at more advanced optimization strategies. And so we know customers, when they're moving to the cloud, are often at different stages of the journey. And so a single tool to sort of service everything has been a very difficult thing to build out. And that's why the team went and built the cloud intelligence dashboards. Again, this is a service that it's not free because it is built on top of AWS serverless technologies, right? But it runs inside your own account. It's pretty easy to use, it's secure, it's in-depth, and it's cost-efficient, again, because it runs in serverless. You're mainly just paying for some quick site to sort of view and visualize the data, as you see over there on the right-hand side. But what the Cloud Intelligence Dashboard was really designed to do was give a suite of insights that would go from the sort of exec level through to the developers, the hands-on keyboards doing work, and be able to give insights to those executives and be able to track and manage things like KPIs through down to the developers, and really create a efficiency-aware organization, right? Because when it comes to cloud, it's no single person inside your organization's job to be cost-efficient. And so that's why when we look at the Cloud Intelligence Dashboards, we actually have, as I mentioned, not a single tool can rule them all. And so we have the Trends Dashboard, the Cost Intelligence Dashboard, Kudos Dashboard, so on and so forth. But you see here, we've sort of built them. They all live off the same data, right? So you're not working off different data where you're going to end up in a situation where, hey, whose data is right, whose data is wrong. It's really presenting that data in different ways based on the audience for what's going to be the most impactful and valuable for that audience member, right? So of course, the executives are likely going to see sort of the Trends Dashboards. The business owners and product owners are more likely going to be spending time inside the KPI dashboards. And then the FinOps, the practitioners, the people that are more likely to be closer to the hands-on keyboards, are going to be spending more time in Kudos, and then the Compute Optimizer dashboard and the Trusted Advisor dashboard, because that's another thing I wanted to mention. With these dashboards, we actually bring multiple AWS data sources together so that you, again, can have that single pane of glass view across your leadership team through to your developers, so that you can track and make progress on your efficiency and optimization goals. If anyone looked at these dashboards 2 years ago when they sort of started, it was relatively cumbersome to get going. These days, we've now got this to a point where it takes about 30 minutes or less to get all of this set up, okay? It is really pretty quick. All of the data stays inside your accounts, right? So you don't have to share it with any third party. It's pulling AWS data already in your account, making it easy to view. Another really nice thing that customers like about this, if you're in this pain point, you'll know the pain. These dashboards can operate across multiple payer accounts, okay? So if you happen to have an organizational structure where you have multiple payers, in addition, obviously, to multiple children under each of those payers, again, this can provide an organization-wide single pane of glass view into that. And again, it's highly customizable because all of this is open source. Obviously, like the Compute Optimizer dashboard pulls in Compute Optimizer data, but all of the code to deploy, run, and manage these is open source. So if you want to customize it, if you want to make it specific for your organization, you can take that and run with it and customize it to your heart's content. And it is built on our serverless technologies. We don't need to go into this in this session here, but in case you're wondering sort of the tools and components, how it all stays in your account, how it all comes together so quickly and easily, these are the different serverless components that come together to deliver the Cloud Intelligence Dashboards framework on your behalf. All right, on to our last three here. So Graviton. Maybe it's not that new and exciting anymore, but Graviton 4 was just announced. And so I bring this one up at this point because it's generally something we're seeing customers get to when they've already done those simple steps. Of course, there's no reason you can't move straight to Graviton. In fact, there's many applications that you can just go run on Graviton immediately today. But I bring it up in this section because it's one of those ones that's going to continue to pay those benefits to you in years to come. we just heard the announcement, or hopefully most of you that attended, just heard the announcement of Graviton 4, the next generation Graviton 4 instance type, which has 30% better CPU performance. I think it has 50% more CPUs and 75% more memory. I'm going to focus specifically on that 30% better CPU performance though, right? Because this is something that I think it's not obvious if you're not in the Graviton world, but Graviton is continuing to make significant performance leaps in each generation, right? So we saw a double-digit performance improvement from Graviton 2 to Graviton 3. We've just heard 30% performance improvement from Graviton 3 to Graviton 4, right? And so if you are going onto Graviton, if you have already migrated, or if you're considering migrating, don't just look at what you'd expect the immediate savings would be. Those will be compelling, don't get me wrong. But if you move to Graviton, on Graviton 2, you would have gotten about 40% price performance improvement over comparable x86 instance types a couple of years ago. And then we've seen double-digit performance improvements twice since then, when x86 is doing single-digit percentage improvement and moving at a slower clip, right? So with Graviton, you're getting significantly better price performance, and your applications, as we add new generations, are getting those huge leap forward where you can add even less servers, or maybe just service more customers with the same number of servers, whatever it may be. But that's why I sort of consider this one of those ones that are going to continue to pay significant benefits for customers who are adopting. And I mentioned this to somebody in the pre-chat, but what I think is so powerful about this Graviton platform is that we can actually go and look at what are those bottlenecks, right? Of course, we're not looking at any of your specific data, but we see the workloads running in the cloud. We know what the performance bottlenecks are. We know what's driving costs into those compute environments. And that's why not only are we still sort of developing this overall environment so rapidly, but we're actually making sort of the right leaps forward, which is how we're able to get these double-digit performance improvements, because we have the data, right, to make these intelligent decisions as we're designing the next generation of chipsets. I'm going to skip this next slide because I wasn't allowed to put the Graviton 4 slide in case Adam didn't announce it, but the Graviton 3 slide now seems a little bit redundant. But you know the story for Graviton, and I guess here, in case you're not aware of it, right? People think about Graviton, the original A1 instance, and Graviton 2, Graviton 3, now Graviton 4. But we actually have a lot of these components are actually embedded in our overall environment, right? The intelligence we've gotten from designing and building our own silicon is not just in Graviton, but it does play benefits to Graviton, right? The Nitro security chip, that's also our own custom silicon. The Nitro card, we've designed that from the ground up as well. And then finally, of course, the Nitro hypervisor, which is what provides sort of the base level of incredible performance you generally will see on EC2, right? Where you will get that fantastic performance out of these instances that you really won't see in hypervised environments almost anywhere else, right? And so these components, these are exclusive, purpose-built, and they're modular building blocks, and that's why we're able to continue to make these pretty significant leaps forward in this overall Graviton system that we're operating today. If you're thinking about Graviton for EC2, good on you. If you've already adopted for EC2, 10 points, even better. However, if you haven't adopted Graviton at all yet, and you're wondering where to get started, my answer is actually not EC2. It's fine if you want to get started with EC2, but we have a whole bunch of managed services. You click a button, you get the benefits we just talked about, because we've already done all the qualification of the software, right? We own and operate that. Well, we operate that ourselves on your behalf, so you don't have to, right? And so if you haven't adopted Graviton, are you using RDS? Go click the button. Elasticache, go click the button. Or even things like EMR, right, where it actually is your own EC2 instances. You go click a button. They're just really quick ways that you can really start reaping huge benefits. And what we see is customers that do that, particularly if any of you are in the audience, and I do hear this from a lot of folks that tend to attend these conferences, again, generally from like a central infrastructure, cloud, or platform team, they might be struggling to convince their developers that the developers don't know if it's going to work and don't even want to explore it. We've seen some people just boldly go and move them to Graviton. It works sometimes. It's a bold move. But even better, just go move your AWS managed services to Graviton, and they will see that it is real, that they do get these price performance benefits, that they do get better overall latency and performance for many of their applications. And that is a great way to then go and convince them, okay, hey, we saw this, we proved it out with our managed services, we saw it for ourselves in the real world. Now it's worth spending that time to qualify and confirm that our applications running on EC2 can make this leap as well and start reaping the same benefits. All right, second to last here, folks. Thank you for staying with me. So serverless, we're obviously mainly focused on compute in this session, but I always like to mention serverless because, as Werner Vogel says, there's no server that's easier to manage than no server. So if you do have applications right now where you've got servers running, and there's particularly if you have applications that have a lot of idle time, right? Moving to a serverless architecture is a fantastic way to stop paying during that idle time, right? Because with these serverless systems, you're generally paying for requests when your customers are actually using your platform, internal or external, whatever it may be. And so for us, that serverless is all about that. No infrastructure provisioning, the automated scaling, you pay for what you use, all of that type of work. But again, just like with Graviton, if you haven't started your serverless journey today, there might be paths for you to explore that actually sit outside the EC2 or compute portfolio that you haven't already checked out. Right, so we have service offerings across compute, of course, Fargate, Lambda, two of the most popular. But things like our data store services, so if you're using Amazon Aurora, there is a serverless option. And of course, we have all of our integration services like the API gateway, step functions, these types of things that are serverless offerings as well that can replace a lot of the sort of glue that you might be running on EC2 instances. And that glue is very often idle. So it's a great way to go and reduce costs, maybe improve uptime and performance as well for your applications. Then finally, the final piece that for me, this might feel a little bit out of the blue, a little bit random for those of you who know Carpenter. Quick show of hands, who does know Carpenter? Okay, very, very unknown, okay. So who knows Kubernetes? Okay, good. We're in the right world then. So Carpenter is the AWS-built provisioning system that you can replace the cluster autoscaler with. Right, and so Carpenter was actually built by AWS. It is open source, but it was designed by AWS to really optimize cloud, EC2 compute services in particular, as much as possible. And in addition to optimizing it, it does things like help improve upgrades and management, and particularly help run platforms that have multiple different types of applications. So it's a high-performance scheduler. The reason I bring it up, though, is if you are either in the process of migrating to Kubernetes or if you're already running on Kubernetes and you're thinking about the 6 or 7 things that I've talked about today and thinking, geez, that's a pretty long list. I don't know if I can be bothered getting started even with the first one on that list. I understand. Carpenter actually does almost the whole list for you, right? With Carpenter, I'll show you quickly how it works. Right, this is how the old system used to work with a cluster autoscaler, which would then call an autoscaling group. An autoscaling group could only be a single instance type. Right, and so if you wanted to run multiple different applications on this cluster, maybe one of them needed high memory, one of them needed GPUs, one of them needed high CPU, what are you going to do? Are you just going to run super unoptimized with a single instance type? So we actually said, well, we can do better, we think. We can replace those components with Carpenter and EC2 Fleet. And so what this thing is actually doing, let's talk about the steps. So for scaling, number one, Carpenter automatically looks at the containers that are to be scheduled, and then it's automatically going to add the correct number of nodes on your behalf, right? So it's automatically scaling. In addition to that, it actually looks at the pods, at the configurations in the pods and says, because you don't have to provide instance types to Carpenter. So it looks at the specs and says, hey, it looks like these next containers that we're about to go and deploy, they take about this shape. This is the optimal shape for the next set of containers that we're about to deploy. And so it'll actually automate the process of finding out of those 750 plus instance types, which are the ones that match the shape for your application. And then with EC2 Fleet, automatically select the cheapest. Or with Spot, automatically select the one that's price and capacity optimized, right? So it does that out of the box on your behalf. So that's automated scaling and automated right sizing. And if you have sort of missed that point, the idea that it automatically selects the instance type means it also does the Spot stuff we were talking about. Remember how I said you have to be instance flexible? Well, it's going to automate that process because if the very first option it tries to select for Spot isn't available, it'll just move on to the next one, right? It's going to automate that process on your behalf. So it's really putting a lot of these pieces together in an automated way. You do still have to purchase your own savings plans. I should have mentioned that. If there's a base level in your Carpenter environment, you do have to go purchase your own savings plans. It's not going to automate that process for you, but the rest of it, it's doing a really good job of. It is native to Kubernetes, right? So if you are using things like taints, affinities, what else is here? Node selectors, topology spread. it's going to listen to those, it's going to honor them, right? It is a native Kubernetes service that's designed to work with native Kubernetes capabilities and functionalities. And I already mentioned this, right? It's using that sort of attribute-based instance selection concept. It doesn't actually use attribute-based instance selection, but it does the same thing on your behalf under the covers. As I mentioned, it's going to automatically select the cheapest on demand or the price and capacity optimized spot instance on your behalf. And then the final thing that I really love about Carpenter, which I think to me is sort of the spirit of what containers was always meant to be. And time again, I see customers that we haven't yet achieved this universally until I meet customers that are running with Carpenter. With Carpenter, it's going to do automated node consolidation as well, right? So if you're running a container environment, hey, we should go from 100 down to 50 nodes now because we've got all these nodes, the containers spread. You've sort of ended up fragged. It's going to automate the process of then defragging your environment to minimize your compute costs on your behalf. So if you take away only one thing from this presentation, this would be it. If you're using Kubernetes and you want to apply almost everything we talked about today, and you want your infrastructure platform team to be excited about it, maybe even your developers to be excited about it, because it really does give them a lot of freedom, just jump straight to Carpenter. This is a great way to deliver that agility for your business while getting all of the optimizations we talk about throughout today's session. And with that, I'll thank you very much. If you enjoyed the session, I will encourage you to fill in the survey. If you didn't, feel free to just come up and yell at me at the end personally, if you'd like. But yeah, thank you very much for your time. Feel free to run to your next session as quickly as you can.